Hi friends, welcome to GMK tutorials. In this video, we are going to see about the smoothing of a spatial filters. Generally, spatial filters means that spatial filters. So generally, what is meant by filter? Filter means that it is a frequency domain meaning actually. So the filter means that which allows or maybe which rejects or allows certain frequency. So based on this, you can categorize the low pass filter or high pass filters like this also. So spatial domains means that the low pass filter allows the frequencies in the corresponding low frequency range. So it performs some smoothing operations. Likewise, in case of the spatial domain also, some filters are there. That filters are generally called the smoothing spatial filters. Smoothing spatial filters. Smoothing spatial filter. So smoothing spatial filter means it is also simply called as a average filters. So we can call this a average filters. So average filter means here generally we are taking a one mask. Mask is also called as a spatial kernel. There are some other names for this mask, like mask is kernel. We can call it different names actually. I think all of you are having some box filters like, right? So spatial filters can be called as a mask or maybe templates or windows. These are the different names for spatial filtering. If the operations are performed in the linear fashion, we can call it a linear filter. Otherwise, it is called as a non-linear filter. So average smoothing means just if you are taking the average of all pixels. So the each and every coefficient of this filter is 1. If you are suppose if you are taking a original image, these two are multiplied with the corresponding pixels. So if you are getting the suppose it is also consisting of a different values, 15, 10, like this, any values, random values. If you are multiplying the same kernel with this one, you will get some value. That value is divided. That means the product of the course. Suppose if you are taking let it be considered for analysis point of view. Suppose if you are placing a kernel in this place, what is the average? What is the total value? If you are performing some dot operation, point to point multiplication, so you can get 15 plus 16, 15 plus 1, 16, 17, 17 plus 3. 24 plus 6, 24, 30, 35, 36, 37. That means overall values is equal to 37. 37 divided by average. Average means a smoothing, right? So 37 divided by 9. So generally, if you are dividing this one, so we can get 4. 9 4s are 36. So actually the central pixel value is 6. If you are smoothing that corresponding value by using a smoothing filter, this value can be reduced to 4. That means the intensity value can be reduced to some below average value. So that's why the image smoothing can be attained in the spatial domain. This is the one way of image smoothing. So based on that means here the complete averaging can be decided by this mask only. This mask decides the corresponding average value. So based on this one, we can performing the averaging of the spatial domain. So there is another mask is also there. That mask may be consisting of a different mask, also having a different weighted coefficients also. Suppose let us see one general example for another mask. Suppose if you are taking the 4x4 mask filter, it's we can also call it a kernel. So the kernel coefficients values are internally, sorry, it is also a 3 by 3 matrix initially, sorry. So if you are taking it's precast. So here the values are filter coefficient values are 1 to 1, 2, 4, 2, so 1 to 1. So this is also, this filter is generally called as the weighted filter. So weighted average filter. The weighted average filter means that the filter coefficients are not same. So each and every filter mask is multiplied with some different value. The main intention behind this one is nothing but it gives more blurring. That means if you are moving from origin to central pixel to away from the central pixel, the image blurring can be reduced. That is one of the basic advantage of these kind of filters. Here the filter coefficients are maybe different values. In the previous case, all filter coefficients are equal to 1, 1, 1. But if you go for this scenario where filter coefficients are 1 to 1, that means the central pixel value having a highest weight value, and moving from the central pixel to away from the central pixel, we are reducing the values also. That means the corresponding weight, that means reducing the blurring in the smoothing process. So for that purpose, we are using the smoothing filter. So this is also another smoothing filter example. So second thing, one more filter is there. That filter is generally called the order statistic filter. We can also call it a median filter. Order statistic filter, we can also call it a median filter. Order statistic, we can also call it a nonlinear filter. Order statistic, or median filter. So in this process, what happens is that suppose if you are taking a 3 by 3 cross 3 matrix, is a filter like, if you are taking like this 5, 6, 7, 4, 3, 2, 9, 8, 2. So in this case, what happens is that first of all, you have to write the corresponding values in the increasing order. If you are taking the 3 by 3 class, or maybe 5 by, suppose if you are taking the any image like this, or if you are taking a 3 class 3 mask. So in this case, first of all, what happens is the corresponding values can be represented in increasing order. 2, 2, this is over, then 3, increase 4, 5, and 6, 7, 8, 9. Now you have to write the corresponding values in the increasing order. So what is the middle value here? Middle value, so this 2, so this also not. So the middle value is 5. That means the central pixel value 5 is replaced with the corresponding value. So like this, we can enhance the corresponding values. The order statistic filters are very helpful for reducing the noise content in the corresponding images. Like it is very effective for salt and pepper noise cases also. This median filter is very effectively working for reducing the noise content. So this is just a brief introduction of what is meant by filter, how we are going to performing the filters like this. So if you are closely related, if you are looking very closely, generally this the basic behind the concept of all these cases is nothing but, generally in case of the primary classes, we know that T is equal to R. So here R is nothing but input image pixel, That means if you are performing some operations on the input pixel that result into some output pixel, yes, this is nothing but pixel operations, or we can also call it as spatial transformations. Okay, single pixel. But if you go for the second one, is nothing but neighborhood operations. In case of the neighborhood operation, what happens is that instead of taking the single pixels, we can take the consideration of one surrounding pixels also, neighboring pixels also take into the consideration. We can decide the corresponding value. So in this case, how we are going to write g of x comma y is equal to, suppose if you are taking the f of x comma y is the input pixel. Now if you are performing t of f of x comma y, it is a notation, right? That means if you are performing some operations on the input image, or we can call some sub mask, it produces some output image. That output image can be represented g of x comma y. This is generally called the spatial domain representation of the corresponding image. So obviously there is a doubt for this one. Sir, what is meant by this? This T is nothing but some spatial operation. It may be averaging or median filter or whatever the filter. where processing on the corresponding input image, the resultant value can be produced on the values. So this is generally a spatial operation. The name of the topic is nothing, simply we can call it a spatial transformations. Spatial operations. That means we are performing spatial domain, right? Spatial operation. So in case of the spatial operation, what we are going to do? So it is for a single pixel. First one is nothing but single pixel operation. So in case of single pixel operation, directly where it is nothing but input pixel, so it is nothing but output pixel. Okay. So in case of the neighborhood operations, or what we are going to perform is nothing but just you have to take some neighborhood of the image, then you have to process the corresponding image. We can map to the same image. So let it be considered any kind of the operation. Suppose that may be any average also. Suppose g of x comma we say output image is equal to 1 by mn, smoothing of corresponding f of x comma y also. Suppose let it be considered t comma some dummy numbers. Actually the same numbers cannot be permitted. That means the location may be shifted, right? So for that purpose, just I have to change the letters. This instead of this one, we can use another. So f of t comma s. So t comma s. Let it be considered t comma s is the output pixel in this case also. So this is nothing but just spatial operations on the spatial operation. So this is for single pixel. It is for neighborhood operations. So neighborhood means the pixel value can be replaced by the remaining consideration of the pixels also, the neighboring pixels. That's why it is called as neighborhood operations. Another transformation is also there. That is nothing but geometrical spatial transformations. That is completely decided by the some transformations. Like generalized equations is nothing but spatial transformation is equal to geometrical or spatial transformation. So geometrical operation. So this is just a brief introduction. It is not a concept or origin. Just I will recap this what is meant by what. So in case of the transformation of the corresponding geometric transformation, we can represent x comma y as the locations. So that is nothing but t of u comma v, u comma w. So here t is nothing but we can perform any kind of the operation. So it is also called as the affine transform. Based on this value, we can choose like x comma y comma 1 is equal to v comma w comma 1 into some transformations. So this is the general procedure where t is nothing but some values is there, that is equal to some affine matrix. So t11, t120, t21, t220, last 231, 320. So based on this one, we have some shapes like such a kind of the identity matrix, such a kind of the affine matrix where T can be replaced with any matrix. It may be identity matrix, scaling matrix, rotation matrix, scaling or identity, rotation. If you are changing that, well, obviously overall values also changes. That is just a brief introduction about the spatial operations. So thank you for GMK tutorials for watching.